This week you're working on the toe stop assembly or capstone project 1.1. In the textbook, this is where it starts right here in the textbook. We are going to do the 2D variation of it. There's a section in the text there that deals with 3D modeling for it, but we're not going to do that. If you want to do that on your own time, feel free to go ahead. But whatever you turn in has to be the 2D drawings and file. So it starts here. This is an exploded isometric that you're going to do. There are some videos that if you want to download them to follow along with, that would be fine. But we are making some changes to the project based from the textbook and from their videos. Next page has the dimensions for all the parts and their name and their material, their notes. Okay. The hex cap screw, the nut, and the washer are a block that is in the prototype file that you're going to use, so you don't have to draw those. And I'll say it now, you need to download and use the prototype file from Blackboard because the one from the publisher has the wrong blocks in it. So I've corrected that in the one that's in Blackboard. Okay. So download the prototype file from Blackboard. I've already set up dimension styles and layers for you, so you do not need to make any changes to the dimension style. I don't know why it says to use a D-size sheet here, because the title blocks they provided are for a B-size sheet, or 17 by 11. Yeah, all of this right here is good. Here's a sketch of what detail sheet 1 is going to look like. So what you would normally call the top of this toe stop is going to become the front view. And then we'll do a full section view up above it and a side view to the right. And then you'll draw the cleat pin also on that same page. Detail sheet 2 is going to be the cleat, and we're doing this layout of the drawings, okay, of the views, and then just notes for the fasteners. There's no need to draw and dimension fasteners if they're standard, typical things. So we just put a note as to what we need for there. And then it goes into instructions on some of the drawing. Okay, and so your isometric drawing is going to look like this. There'll be a parts list that you'll fill in. Then there's some instructions on drawing isometric counterbores and countersinks. Okay. And then some instructions on how to create the slots on the bottom of it. Okay, so now then let's go to AutoCAD. Let's go to the prototype file. Okay, so here's the prototype you're going to download. You'll do your drawing here in model space, of course. You can use the starting point grids here if you like. I would say yes, use them to start with, and then you'll end up kind of moving your stuff around a little bit. But when we go to the pages, here you can see the parts list is here. It's just a table. You click on it, you click in the cell, and you type whatever information you want in that particular cell, just like in a word processor, okay? The title block, like the last drawing, you double click the title block and it opens up the attributes. You select it and then type in what you want to show up on the title block. Okay. Detail sheet 1, same kind of thing. Here's the note over here, and you just copy and move it into the drawing sheet, and then click it to fill it in. Same way on sheet 2, there's the note that you can copy and bring over here. All right, now like I said, the layers are already created, the dimension styles are created, and there's just like with the last drawing, there's a balloon multi-leader that you can use to do the part number balloons with. So let's go to the actual drawing. So with your isometric, I started it, I just drew a diagonal line from corner to corner, and then I centered this circle on the midpoint of that line, and then I drew the toe stop. Okay, and so I drew that, and then once I had an idea of how it's going to shape up, then I just grabbed it and moved it down to the side a little bit. What you want to do with the trails, we call these lines trails, is they're on the phantom layer, and they should come from the center point of the holes. And I think I brought it up like an inch. Brought it over, I don't know, 2.5 to 3 inches, and then up another inch. And then you can, to draw this one, I actually started with this top surface and then copied my lines down to get the bottom of it. You needed that midpoint of this because this cylinder down here on the bottom is concentric with this arc here. So I find that midpoint there and project it down and kind of working through it. And then you can grab the whole thing and move it to as you like. Now the nut and the bolt, you're going to insert a block. It's real simple. You go insert and you pick which block you want and grab it and drag it in here. Now once you get it in its final location that you want it, you're going to have to do some trimming because in an isometric view we assume that the parts are solid. And so what you'll have to do is select the block and explode it so that you can do trimming. And you can notice here I trimmed out part of the cap screw where it comes down, and I trimmed out part of the washer where it goes behind there. And then I just changed it back to the visible layer. Same thing down here. You want to trim out the lines of the toe stop that go behind the cap screw. These down here, there's no need to explode these because there's no trimming going to go on with those. Okay. That's pretty much that. So let's move over to this view. Like we said, the top is going to be in section, so there'll be hatching in there. You notice there's no horizontal center line through here because we got a cutting plane line that's going to go on that over in paper space. Now we have a unique situation here in which we have two holes that intersect. Okay, we've got the large hole here, and then we've got a small hole coming into the side of it. And where they intersect, if you look at it from a side view, it is not just a straight line because the edges, like right here where the hole intersects, is further down than the top of the hole here. And we're looking here, this is the top of the small hole, and then it comes down. So what we do is we draw an ellipse in there, and I'll show you over on this side. We don't really have we have a hole going through a cylinder, but it's the same process. And so I'll show you just on my zero layer. I want to put a line from where the small hole intersects the outside edge, because this point right here is already projected over. It's the edge of the cylinder. And so the hole is actually going to dip down to there. And so from that point we draw an ellipse. So I go to my ellipse command, and I want to use the endpoint option. So I go from edge of hole to edge of hole, and then bring it down to that point. And I would trim those lines out. And in this case, I would put this one on my visible layer. And then I can just mirror that down to the bottom and then trim that out. Okay, now the ellipse it's not totally accurate as far as the shape that hole would make, but it's close enough for what we're dealing with. Okay, so anytime you have anytime you have two cylinders that intersect each other, you're going to have an ellipse of some kind where they join. Now let's look at the drawing sheets. The exploded isometric is not going to be to scale. I put mine at a, I just use the mouse to scroll it. It's 0.397, so somewhere around 0.4 would be fine with the scale. And then once you get your scale set right, move it into the right location, and then lock your viewport so things don't move around on you. And then you'll place the parts balloons, just like we did on the last assignment. So you just go multi-liter, make sure that's set, bring it in, and you type in your number. And the number of the balloons go along with the numbers in the parts list. Okay. And when you enter this in, I want to say that this column here was had a right justification, and so did the quantity column. So once you get your information in, you can click one and then hold down your shift key, click the bottom one. And then up here in your table cell tab in the properties up here, this one is justification. And when I opened it, it was set to top right. So just change it to middle center, and that will force all your text to be in the center there. And do the same on the right column if that one is that way also. Okay. Detail sheet 1. Do all your dimensioning here. Draw your cutting plane line here. And okay, so line type scale, because this drawing is coming in at a 1 to 2. My global line type scale is 1. But I need to adjust the line type scale on some individual lines. This for sure, in properties, I changed it. I think it's a 0.25. Let's see. These right here need to be changed. 0.5 didn't work. Oh, maybe it did, because that's like way too much. Yeah, and even that looks kind of small there, but that might be the best we can do. So use individual properties to set line type scale for these things. And then your notes, you'll bring your notes, copy that over and fill in your notes. Check your decimal precision on most of these are 2 decimal places, so you could change your dimension style default to 2 decimal place precision, but some of them are 3, like this one right here is 3 decimal places. And then your whole note, look back, I think it was chapter 8 that covered how to do the dimensioning for these whole notes using the GDT font. Let's go to detail sheet 2. Check your center lines and line type scales for those. Move your text information in, and then you would fill in just like it is shown in the textbook for the fastener information. Okay, and I think that covers a lot of stuff in here. I would recommend before you turn it in, go ahead and turn off those 2 layers in your construction layer if you wish. Save your file, submit it in the Blackboard, and then next week when you come in to do your in-class drawing for next week, you're actually going to print these on the plotter and turn them in. And the grade for that is just following the instructions to make the prints, and then you can come back and pick those drawings up later and take them with you if you would like to have them. Okay, I think that that covers the project for this week. If you got questions, send us an email or come to the lab to get some assistance.